In the previous video, we already discussed the mathematical expression for the two levels of profit, profit 1 and profit 2. Okay. We also said that to maximize its profit, the change in profit, which is delta profit, should be equal to 0. In this video, we're going to continue our math work and figure out, what a typical firm on a perfectly competitive market need to do to maximize its profit. All right, and more specifically here, we just plug in what we already got for profit 2 and profit 1. Okay, so here, once again, this is the total revenue after raising the labor by 1 more unit and minus the labor cost and minus the capital cost. Okay, and minus, so here within the square brackets, this is profit 1. All right, and the first 3 parts are profit 2. Okay, please keep these square brackets here when you just plug in. Okay, otherwise you would mess up with the signs here. Okay, I saw this happening every year, with many students. Okay, the next step, we're gonna remove the square brackets. Again, here, because in front of it we see a minus sign, so here you have to be careful about these signs. Okay, because minus times minus, we should get a plus. Okay, all right, so here is what we got. The first 3 I'm sorry, we also open these brackets. Okay, L1 plus 1, so what you got is P, price, times the output, okay, minus nominal wage times L1 minus W. So we open the bracket, so the W minus W times 1, that's how we get minus W here. And the capital cost stays the same. Okay, and then we open the square brackets here, so it's a minus sign in front of the P times F as a function, okay, of K1 and L1, and here becomes plus, okay, because minus times minus, plus W times L1 plus R times K1. All right, and we find that here we have a minus W times L1, we have a plus W times L1. We have a minus R times K1, and we have a plus R times K1. So these items can be canceled out. All right, and what's left over is P times the output when the firm uses K1 units of capital and L1 plus 1 units of labor, minus P times the output when the firm uses K1 units of capital and L1 units of labor. Okay, minus W, that's this guy here. All right, now here's one more trick we're gonna do here, but it's not a math trick, it's actually an economic trick. Okay, so here we find in the first 2 items the common factor is P, so we're going to take P out. Okay, and what's left over here is the output after increasing the labor minus the output before increasing the labor, right? And this is a very important economic concept, which is marginal product of labor. All right, recall in your introductory course or the intermediate micro course, we said that marginal product of labor means the extra unit of output the firm can produce by increasing its labor, increasing 1 unit of its labor. Okay, so that's exactly what we have here. All right, so what we got is P times MPL, marginal product of labor, minus W, which is this one here. We set it equal to 0 because that's our condition for profit maximization. Okay, so here don't be confused. We're not saying that delta profit or the change in profit should always be 0. No, but what we're saying here is when the profit is maximized, this change in profit should be 0. Okay, so when you slightly change the labor, the profit won't change as a result. Okay, all right, so here what we could do mathematically is we could move this W to the right hand side. Okay, so here is a typo. Here it should be P times MPL equals W. Okay, the nominal wage, or we could divide it both sides by P. So we're gonna get marginal product of labor equals W over P. Okay, all right, so this is what we are looking for. Okay, eventually we find this if capital is held constant. Again, here the only factor we changed is labor. Okay, capital stays the same, K1. It's always K1. All right. Similarly, you can hold labor constant and change your capital by 1 unit. Okay, and as you could guess, you should be able to get this equation: marginal product of capital equals real rental, the rental price divided by P. Okay, if labor is held constant. Now on the worksheet, I will give you a chance to drive these on your own. Okay, you can just go back and look at what we have been gone through, and you can just simply mimic what we did step by step. Okay, instead of again using L1 plus 1, you're supposed to use K1 plus 1. Okay, your L1 stays the same all the time because labor is held constant. Okay, now on day 1 of this semester, I said that compared to the intro class, here this intermediate level course will give you more chances to do math and graphical analysis. Okay, however, we don't want to be too busy with the math or the graphs. We should always put the economic intuition behind math and graph. Okay, so here, what is the economic intuition of these the condition for profit maximization? On the left hand side, it's a marginal product of labor, right? So that means this is the unit of output a worker produces for her company or for the production. Put differently, this is a worker's contribution to production. All right, and on the right hand side, it's nominal wage divided by the price of output, and previously we said this is a real wage. Okay, this is how much the worker gets paid. All right, so you would find these two are equal fair enough, right? Your contribution to production equals your how much you get paid. Okay, so that's the economic intuition behind these two equations, because we have another one for capital, right? Again, here you would have a chance to rethink about what we have done here. We spend a lot of time doing the mathematical derivation, do the algebra, okay? But when we look at the economic intuition, we probably only need 1 or 2 minutes to explain the idea. Okay, the idea itself is very simple. Your contribution equals your how much you are gonna be paid. Okay. All right. So this is you know, our I'm sorry, the math derivation, okay, about the profit maximization. Okay, and the next thing we're gonna try is we're gonna look at the graphical way to figure this out.